Alright, this LeetCode question is called delete node in a linked list. It says write a function to delete a node, except the tail, in a singly linked list, given only access to that node. So given the linked list, which has a head of 4 and the rest of the linked list is 519, let's say we're only given access to the node 5 and we want to remove it, the output should be 419. Example 2, we're only given access to this node and we want to remove it. We want our final answer to be 459. Then it says the linked list will have at least 2 elements. All of the node's values will be unique. The given node will not be the tail, and it will always be a valid node of the linked list, and do not return anything from your function. Alright, so let's say we want to remove the node 5. Usually when we want to remove a node from a linked list, we have access to the node in front of it. So usually what we do is we just set the property of the node in front of it to the node after the node we want to remove. So in this case, we would have at the end 4, 1, 9, null. But what this question is saying is we don't have access to the node in front of us. So we'll get rid of all this. So it'll look more like this. We want to remove 5 without knowing what's in front of us. So just to represent a linked list another way, let me bring this up. So if we look at this, the first value is 4, and it has a next property that's pointing to a node with a value of 5, that has a next property that's pointing to a node with a value of 1, etc., etc. And as we can see, each node is very simple. It just has a val property and a next property. The key to solving this is all we really have to do is make the node we're on look like the node that's after us, and then point our next property to the node after the node that we're pointing to right now. I know it sounds confusing, so I'll show you what I mean. So just remember that we're talking about the node 5 as the one that we want to remove. So we'll just make 5, instead of 5, we'll make it 1, which is the same as the node after us. Down here, just to show you what it would look like more in the code, this value would be 1. Alright, so far we have 4, 1, 1, 9, null. Remember what we need is 4, 1, 9, null. And we still just have access to this node. But all we have to do now is point this arrow, instead of to the node after us, we'll point it to the node after that, which would look like this. 1 now points to 9. So if we look at it, our linked list is now 4, 1, 9, null. We've successfully removed the number 5. So the final step down here is the next property for the number 1. Instead of pointing to what we had before, which was next, which was the node with the value 1, we'll point it to next dot next, which is the value 9. Alright, so LeetCode has given us a function named delete node, and it accepts a node. Remember, this is not necessarily the head of the linked list. It's just the node we want to remove. Alright, so if we look to the left, each of these arrows is just this node's dot next property. So 5.next points to 1, 4.next points to 5, 1.next points to 9, and 9.next points to null. Alright, so let's just pretend it's the number 5 that we're removing. Remember, what we have to do is we have to change the value of the node to the value of the next node. So that would be node.val, which right now is the number 5. We're going to change it to node.next.val. So if we're on 5, .next points to 1, and we'll change it to that value, which is 1. All right, so now our 5 becomes the number 1. And the only thing we have to do next is change the next reference of the node we're on, which is pointing to the number 1, to the reference of the next node after that, which is pointing to the number 9. So our code is just node.next, which again is pointing to the node after it that has the number 1, to node.next.next, which is the number 9. So we're here, node.next right now is pointing here, but instead we're going to have it point to node.next.next, which is the number 9. So that would look like this. Now this points here. So just note that since nothing in this linked list is pointing to this node anymore, our linked list is now really just 4, 1, 9, null. All right, let's run the code. Looks good. Let's submit it. All right, so our solution was faster than about 29% of JavaScript submissions. As usual, the code and written explanation are linked down below. If you liked the video, give it a like and subscribe to the channel. See you next time.